हरिः कर्ता।
Now let's see more about the correlation and covariance. So as we have a covariance matrix, and similarly we'll also have a correlation matrix. So what's the difference between the covariance matrix and correlation matrix? A correlation matrix can be defined as a matrix with correlation coefficients among different variables. The connection between two variables is represented by each cell in the table. A correlation matrix can be used to summarize a data as an input to a more advanced analysis or as a diagnostic for further studies. So when developing a correlation matrix, a key considerations include using correlation statistics, variable coding, missing data handling, and presentation. So we will see we have seen correlation, how to calculate the correlation. We'll see the new perspective of calculating the correlation. So that's using this rho xy is the another way of representing the correlation, or just correlation of x comma y. That's a correlation of x variable and then y variable. So that's what. So you can use the covariance formula in correlation and you can calculate the correlation. Okay, so you can take up as covariance of x comma y divided by square root of variation of x and square root of variation of y. So square root of variation of x is nothing but the standard deviation of x, and square root of variation of y is nothing but the standard deviation of y. So if you put the things in a much simpler way, so correlation of x comma y can be calculated using a formula which is a covariance of x comma y divided by multiplication of standard deviation of x and standard deviation of y. This is another way of calculation. So positive correlation occurs when two variables move in the same direction. When variables move in the opposite direction, they are said to be negatively correlated. So now there are three types of correlations. Of course, we have seen before, that's a different one. So positive, negative, no, but this is a different type of correlation. So the first one is simple correlation. In simple correlation, a single number expresses the degree to which two variables are related. That's it. Only the simple correlation is in between the two variables. Then second one is partial correlation. When one variable's effects are removed, the correlation between two variables is revealed in partial correlation. And the third one is multiple correlation. So a statistical technique that uses two or more variables to predict the value of one variable. This is called multiple correlation. We will be doing all this when we enter into the machine learning module. But for now, you just understand what is simple correlation and what is multiple correlation. So multiple correlation is nothing but you have y, one dependent variable, and remaining three or four independent variable. In that case, that correlation between one dependent variable with four independent variables are known as multiple correlation, a statistical technique that uses two or more variables to predict the value of one variable is nothing but the multiple correlation. So, and one more thing, that's a applications of correlation we have seen before. So a correlation matrix is computed for the three main reasons. One, the goal when dealing with large amounts of data to find patterns. As a result, a correlation matrix is used to look for pattern in the data and determine whether the variables are highly correlated or not. Whether the variables are highly correlated or not. For use in other analysis, when excluding missing values pairwise, correlation matrices are commonly used as inputs for exploratory factor analysis. confirmatory factor analysis, structural equation models, and linear regression. When checking other analysis as a diagnostic, when it comes to linear regression, for example, a large number of correlations indicate that the linear regression estimates will be unreliable.